Hi there. We are going to solve multiple problems that are related to sequences. And always remember that sequences is part of algebra. So there is going to be multiple of algebra involved in sequences. So let's look at the first question. In each of the following sequences, let the first term be 4. Generate the first 5 terms using the term-to-term rule, which is given as following. So always when we work in sequences, there is the n and there is the nth, and the term, the term to term rule. So the first n or n, it's going to be the first term, second term, third term, fourth term, fifth term, sixth term, and so on. So they're telling us let the first term be 4. So we're starting here at 4. And they're telling us double the nth term. So it's like double, it means 2 times the nth and subtract 1. So if you go for the first one here, you're going to say 2 times 4 minus 1. So it will be 8 minus 1, which is 7. So the second term here is 7. And then you're going to say 2 times 7, since we found the 7, then we're going to find the 3 here, because in each of the following sequences, let the first term be 4, generate the next 5 using the term-to-term rule. So double the previous term, So the third term, the previous term is the 7. So it's going to be 2 times 7 minus 1, which is equal to 14 minus 1, and it's 13. So we're going to write 13. The previous term to the fourth term is the 13. So here you're going to say 2 times 13 minus 1. So it will be 26 minus 1, and this will come down to 25. Here, so the previous term to the fifth term is the 25. So 2 times 25 minus 1. 2 times 25 is 50 minus 1. It will be 49. So they told us to only find the first 5 terms in this sequence. Let's go to next. In each of the following sequences, let the first term be 4. So, like we explained, there is n, 1, first term, second term, third term, fourth term, fifth term, sixth term, and so on. And then there is the nth. So they told us that the first term should be 4. The first term should be 4. Okay? And the term-to-term rule, as it is explained here, square the previous number. Square, it means the nth number to the power of 2 and subtract 10, meaning if we go to this term, which is 4, so we're going to say 4 squared minus 10 is equal to 4 squared is 16 minus 10, the answer is 6. So this term here is 6 because they say the previous. So the previous term to the third term. In order to find this one, the previous is 6 squared minus 10. So it's 36 minus 10, and the answer will be 26. So this one is 26. The previous term is 26. The previous term to this one is 26. So it will be 26 squared minus 10 is equal to 26 squared minus 10. The answer will be 666. 1, 2, 3. And the previous term is to this one is 66 to the power of 2 minus 10. So 66 to the power of 2 minus 10. The answer will be if you insert this in the calculator, 443546. So it's 443546, and here it will be 443546. Next. So in the following sequences, let the first term be 4. So we are going to start all over again. N, 1, 2, 3, 4, 5, and then the nth. They told us that the first term in the sequence is 4, and divide the previous term by 2. So the nth divided by 2, and then add 4. So the previous to this term is 4 divided by 2, add 4. 4 divided by 2 is 2. 2 plus 4 is 6. So this term here is 6. The previous term to this one is 6. So 6 divided by 2, add 4. 6 divided by 2 is 3 plus 4, 7. So the third term is 7. The previous term to this one is 7. So 7 divided by 2 plus 4. 7 divided by 2 is 3.5. 3.5 plus 4. The answer is 7.5. So the fourth term is 7.5. So the previous term to this one is 7.5. So 7.5 divided by 2 plus 4 is equal to, use your calculator, 7.5 divided by 2, the answer is 3.75 plus 4. So the answer will be 7.75. So the fifth term is 7.75. If we go to the next question, basically this one depends on trial and improvement. So it means that you are going to solve it by trial. In the following linear sequences, calculate the missing terms. So if you look here in the n, 1, 2, 3, 4, 5, and so on. The nth, so the numbers that are given in the sequence are the nth. So the first one is missing, the second term is 4, then the third one is missing, the fourth term is 12, and then the fifth term is missing. Okay, so to be honest, it's only by trial. So if you say here, if I add the term to term rule, okay, so if you say here that from here to here, if I add 4, then 4 plus 4, it will be 8. So let me just make it more clear. Okay, sorry about this. All right, so if I'm adding to this term plus 4, so this one, it will be 8. And then if I add once again plus 4, the answer will be 12, right? So here, what is the number that I will add to this number here to give me 4? So plus 4. So definitely it won't be 1, it won't be 2, it will be 0. And here, if I add 4, then this term here will be 16. It makes sense, right? 0 plus 4, 0 plus 4 is 4. 4 plus 4 is 8. 8 plus 4 is 12. 12 plus 4 is 16. So 0, 4, 8, 12, and then 16. And that's how we found by trial the numbers in this sequence. Now, since the term-to-term rule is plus 4, plus 4, plus 4, so it is fixed throughout the sequence. Can we write here the nth term? Of course we can. So we take the term-to-term rule and we write 4n. And here we're going to say plus a number or minus a number. How do we know that? We take the first n, which is 1. So 4 times 1 is 4. To become 0, we're going to say, so 4 times 1 is 4, because this is the first n. 4 times 1 is 4. To become 0, then we are going to subtract 4. Let's try the second n. 4 times, the second n is 2. 4 times 2 is 8. 8 minus 4, the answer is 4. Let's take the n when it is equal to 3. 4 times 3 is 12. 12 minus 4 is 8. Let's take the n when it is equal to 4. 4 times 4 is 16. 16 minus 4 is 12. So the nth term is absolutely correct. Let's go to the second one. So we have the n, which is 1, 2, 3, 4, 5, 6, etc. And then the nth, which are the numbers of the sequence. The first term here is known, which is -1. The second term is unknown. The third term is unknown. The fourth term is 8, and the fifth term is unknown as well. And like I said, it's always by trial. So if you say -1 plus 3, the answer is 2. 2 plus 3, the answer is 5. 5 plus 3, the answer is 8. 8 plus 3, the answer is 11. So it makes sense. My sequence start at -1, -1 plus 3, the answer is 2. 2 plus 3, the answer is 5. 5 plus 3, the answer is 8. And 8 plus 3, the answer is 11. Since the term to term rule is fixed throughout the sequence, can I write the nth term? Yes, we can. Nth is equal to, the term to term rule is 3, and we immediately write 3 times n, which is 3n. In order to see if we are adding a number after or subtracting a number, we go to the first n, which is 1. And we say 3 times 1, 3. To become -1, it will be -4. So 3 times, okay. So that's how we do the checking. Check on our nth term. So if n is equal to 1, then 3 times 1 minus 4 is equal to 3 times 1 is 3. 3 minus 4, the answer is -1, which is the first term here. Okay, let's try the next one. Let's try the next one. So you're going to say if n is equal to 2, then 3 times 2 minus 4 is equal to 3 times 2 is 6. 6 minus 4 is 2. Did I get the answer? The second term, which is 2? Yes, I did, which means that my nth term is correct. Let's check on it when n is equal to 3. So 3 times 3 minus 4. 3 times 3, 9. 9 minus 4 is 5. Did I get the third term? Yes, I did. So, which means that we can always check on the first 3 terms. That's more than enough. So, which means that our nth term is absolutely correct. Okay. Let's go to the last one in this type of question. In each of the following linear sequences, calculate the missing. So we have the n here, which is 1, 2, 3, 4, 5, etc. And then we have the nth, which is the first term is unknown, the second term is 6, the third term is unknown, the fourth term is -4, and then the fifth term is unknown. And like I said, the term to term rule, we're going to figure it out here. So let's say that from this term to this term, or we always start from here, from this term to this term, for example, that we are subtracting 5. So 6 minus 5. Let's say that we are subtracting 5. 6 minus 5, the answer here is 1. and 1 minus 5, the answer will be -4. Bravo. -4 minus 5, the answer will be -9. The answer will be -4. The answer will be -9. And then the first term, so if we subtract 5, so the first term, then a number that I will subtract 5 from it will give me 6 is 11, right? So it makes sense. We started at 11, we subtracted 5 from the 11, the answer is 6. We subtracted 5 from the 6, and the answer will be 1. 1 minus 5, the answer is -4. -4, -5 or -4, subtract from it 5, the answer will be -9. As you can see here, the term-to-term rule is fixed throughout the sequence. Can I write the nth term then? Of course I can. Nth is equal to the nth to n, the term-to-term rule is -5 times n, which means -5 times n. Sorry, this one is unequal. I don't know why. Okay. -5n. So let's check on the first n. If n is equal to 1, then -5 times 1 is -5, but I want the answer to be 11. So -5 I want the answer to be 11. So -5 times 1 is -5. To become 11, I must say here, to become 11, I must say here plus 16. Let's try. So plus 16, -5 plus 16, different size signs we subtract, and we take the sign of the greater number. So 16 minus 5, it will be 11. Let's try on the next n. If n is equal to 2, so -5 times 2 plus 16. -5 times 2, it's -10. Plus 16, the answer will be 6, which is 6, right? Okay, let's try for the next one. If n is equal to 3, then -5 times 3 plus 16. -5 times 3 is -15 plus 16. The answer is 1. Perfect. So far our answer is correct, which means that the nth term that we found is absolutely correct. If n is equal to 4, then -5 times 4 plus 16. -5 times 4 is -20 plus 16. The answer is -4. So did we get the -4? Which means that the nth term that we found is absolutely correct. Okay. Let's go to the third question here. Below is a sequence of 5 numbers. The first term is given as an expression of A. The term-to-term rule is double the previous term So double the previous term, it means 2 times the nth term. 2, let me write it more clear here. So it will be 2 times the nth and double the previous term and add 5. Calculate the expression for the third term. So we're going to start n as 1, 2, 3, 4, for example, and then the nth, they gave us the first term as an expression, which is a, and in order to find this one or the next term, so we're going to say the second term is equal to 2 times a, because the previous term to the second term is a. So 2 times a plus 5, which will come down to 2a. 2 times a is 2a plus 5. Okay. The third term is equal to the previous term to the third term is 2a plus 5, and since it is an expression, I must place it inside a bracket in order to multiply it by 2. So 2 times this expression is 2a plus 5 plus 5. So it will be, you need to expand. Remember, when I first started this video, I told you that sequences is very much related to algebra. So 2 times 2a is 4a, and 2 times 5 is 10 plus 5. So 4a plus 10 plus 5 is actually 4a plus 15. So the third term is 4a plus 15. In order to find this term, the previous term is 4a plus 15. So I'm going to go here. The fourth term is equal to 2 times the previous term, which is 4a plus 15 plus 5. That's the term-to-term rule. Now we need to expand. So 2 times 4a, it will be 8a. 2 times 15, it will be 30 plus 5. And at last here, sorry about this. And at last, this will come down to 8a plus 35. So the fourth term is 8a plus 8a plus 35. Okay? All right. Below is a sequence of 5 numbers. The first term is given as a. The term-to-term rule is double the previous term and add 5, which we did previously. The sum, which means the addition of the first 5 terms. Luckily here, we found the expression for the first term, the second term, the third, and the fourth, and we can continue with the fifth term. Okay, so if we want to find the fifth term, the previous expression is 8a plus 35. So the fifth term is equal to 2 times the previous expression is 8a plus 35 plus 5. And here we need to expand. 2 times 8a, 2 times 35. So 2 times 8a, it will be 16a. 2 times 35, it will be plus 70 plus 5. And here it will be 16a plus 75. So the expression for the fifth term is 16a plus 75. Now, if we go back to this part, they're telling you the sum of the first three terms, the first 5 terms, which are a plus, the second term is 2a plus 5 as an expression, so plus 2a plus 5 plus the third term is 4a plus 15, so 4a plus 15, and this is the third term, plus the fourth term, 8a plus 35, 8a plus 35, plus the fifth term, because they told me the sum of the first 5 terms. The fifth term, which we found at last, is 16a plus 75. So plus 16a plus 75, they are all equal to 223. Now we're going to collect like terms. A plus 2a plus 4a plus 8a plus 16a, all this will come down to 31a. So it will be 31a. And then 5 plus 15 plus 35 plus 75, it will come down to plus 130 is equal to 223. Now we have a linear equation with one unknown, which is a, and we can solve it by transferring the 130 to the other side of the equal in order to isolate a. So it will be 31a is equal to 223 minus 130. And 223 minus 130, it will be, so 31a will come down, 223 minus 130, it will be 93, and get rid of the coefficient of a by dividing each side by 31. Accordingly, 31a over 31 is equal to 93 over 31. This 31 cancels this 31, so a is left on its own, and 93 divided by 31, this will bring a down to 3. So we found the value of a as 3. Now, if we want to find the value of each expression, if a is equal to 3, so we can replace this a with 3. Here, 2a, which means 2 times 3, 2 times 3 is 6, and 6 plus 5, so this one will be replaced with 11. 4 times 3, 4 times 3, because a is 3 and 4a, it means 4 times a. 4 times 3 is 12. 12 plus 15, the answer, so this one can be replaced with 27. The fourth term, if A is equal to 3, then 8A, it means 8 times A. So if A is equal to 3, then 8 times 3 is equal to 24. 24 plus 35, this one, it will be 59. The last term, which is the fifth term, 16A, it means 16 times A. And if A is equal to 3, then 16 times 3, the answer is 48 plus 75. So the fifth term will be 123. And that's what they're asking for here. Below is a sequence, and we did that, calculate the fifth term. So let's say that one last time, the expression for the fifth term. So the expression for the fifth term is equal to, if we go up, it is 16A plus 75. 16A plus 75. And the A we found, we say if A is equal to 3, because if you remember in the previous step, we found A as 3, and we showed you step by step how we found it as 3. So accordingly, if A is equal to 3, then let's substitute the value of A here. 16A, it means 16 times A. So if A is 3, it will be 16 times 3 plus 75. 16 times 3, the answer is 48 plus 75. And the answer will be 123. And this is how we find the fifth term. We're going to continue in another video. We're going to continue sequences in another video. I encourage you to watch this video a couple of times, to write the questions down, solve them on your own, pause and check on your answers. Keep repeating until you nail it and you get it right completely. Thank you so much for watching, and have a good night's sleep.